Let's look at an example involving the rarity of events. In this problem, we're looking at GPA for 15 students, and I have the data here, but the first thing that I do when I have a list like this is I put it in order. So I've gone ahead and put this in order from smallest to largest. I'm also going to do an overview of the questions. It's asking me for the first quartile, the third quartile, the mean, median, range, S, that's the standard deviation, the interquartile range, the IQR, the lower and upper limits, or the lower and upper fences, to find outliers, and S squared, or the variance. Now I'm going to do everything related to position first. I'm seeing a lot going on with quartiles, median, range, interquartiles, and fences. So I'm going to actually begin by finding the five-number summary here. The five-number summary consists of the minimum, the first quarter, the median, the third quartile, and the maximum. The smallest value in this data set is 1.61. The largest value in this data set is 3.99. I have 15 numbers in this data set, and if I do 15 divided by 2, and I'm going to type this into a calculator. Let me undo that mark there. And if I do 15 divided by 2, trying to cut this in half, it gives me 7.5, or 7 with the remainder of 1. What that means is if I'm looking at my list and I count 1, 2, 3, 4, 5, 6, 7, so that's 7 values here and down. That's my lower half. And if I do the same thing from the top, 1, 2, 3, 4, 5, 6, 7, that leaves me with one value remaining in the center. So when I have an odd number of terms, I don't include the median when I'm determining that upper and lower half. My median, then my leftover number in the center, is 2.48. To find Q1, I want to find the median of the lower half. I have 7 numbers here, so I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. My middle number is 1.9. So my Q1 is 1.9. Sometimes what I like to do is X's or little check marks. I'll do that for the upper half, pair at a time. So there I did the top and bottom value, and I'm going to keep going pairwise, top and bottom value, until I'm left with that middle number. This gives me my third quartile of 3.07. Now that I have the five-number summary, I can calculate from this a few things. I can figure out the interquartile range. I can figure out the range in general. And I can determine the fences, the lower fence and the upper fence. All of this is based off of the five-number summary. I'll start with the range. The range is the largest value. Take away the smallest value. So for this particular problem, that would be my largest value of 3.99. Take away my smallest value of 1.61. When I do this, it gives me a range of 2.38. That tells me how spread out my data set is. So from the largest value to the smallest value, it's 2.38 away. The interquartile range is looking at how far apart the middle numbers are. In particular, it's telling me how far apart Q3 and Q1 are. It's the range of the inside. So if I take 3.07 Q3, subtract 1.9 Q1, this gives me my IQR of 1.17. So I've made pretty good progress already just by finding the 5-number summary. I could figure out the range of the inside box, the IQR, Q3 minus Q1, and I could find the range of the whole data set, taking the largest value minus the smallest value. So I'm going to fill in some of these numbers inside of my open math here. Starting with that first quartile, 1.9, my third quartile, 3.07, my median, 2.48, the range of 2.38, and the inner quartile range of 1.17. All of these numbers are position-based. Outliers are also position-based. They're based off of Q3 and Q1. To find the lower fence, I do Q1 minus 1.5 times the IQR. In this case, that's going to be my 1.9 value minus 1.5 times my IQR of 1.17. I'm going to pull up my calculator and type this in. 1.9 minus 1.5 times 1.17. This gives me a lower fence of 0.145. To find the upper fence, I'm going to take Q3 plus 1.5 times the IQR. Q3 is 3.07 plus 1.5 times 1.17. So I need this inner quartile range to determine my fences. 3.07 plus 1.5 times 1.17 gives me an upper fence, or an upper limit, of 4.825. Let's fill those numbers in here in my open math, and let's see which parts we still have left to calculate. My lower fence, 0.145. My upper fence is 4.825. All of these parts were based off of the positions of the values. The minimum was the smallest, the maximum was the largest, the median's in the center. Q1 is the median of the lower half, Q3 is the median of the upper half, the range is the max minus the min, the IQR is Q3 minus Q1. The values that we have left, mean, standard deviation, and variance, are all based off of the values themselves. To find the mean, or the average, we need to take our values and add them all up, 1.64 plus 2.48 plus ... and divide by the number of terms. In this case, I have 15 students. When I type this into a calculator, I get a mean of approximately 2.58. I also need the variance and the standard deviation. To find the variance, and I always find the variance before I find the standard deviation, I look at the first value in the list minus the center squared, and I add all of them up down the list. So I'm going to show you what that setup here looks like in a second. And then I'm going to divide this by the number of terms minus 1. The first value in my list is 1.64 minus the average I just found was 2.58. So I'm taking the first value minus the average and I'm squaring it. Plus, I'm going to do this for the next value. Next value list is 2.48 minus that center of 2.58 squared plus, and I'm going to do this ... for each of those values. In the previous part, when I was finding the average, I divided by the number of terms of 15. I'm going to divide by one less than that here, 15 minus 1, giving me 14 gaps in the denominator. When I did this in my calculator, and it took me a while to do so, I got 0.6516. To get my standard deviation from this variance, I take the square root of that number. Taking the square root of that 0.6516 number gives me approximately 0.8072. Let's type in those numbers and see how that looks in my open math. And then I want to show you how you can do the same thing in GeoGebra. This one has a lot of parts to it. It's a little bit longer. That's okay. Great. These all look good there. Problem being, that standard deviation calculation, that variance calculation, that takes a long time. So one thing you could do is you could type all these values inside of GeoGebra. So what I did here is I went to geogebra.org. I went into the option for spreadsheet, and I typed all of my data here in this first column A. I'm now going to click the button that looks like a histogram. I'm going to do one variable analysis. And then up top, there's a button here, this sigma x, looks like a spicy E, x. And when I click that, it gives me my mean, 2.58. That looks great, that's my mean. My standard deviation of 0.872. I can find my s squared by literally squaring that number. And there's my 5-number summary. My minimum 1.61, my first quartile of 1.9, my median of 2.48, my Q3 of 3.07, and my maximum of 3.99. So when you're doing these problems, I would recommend doing a couple of them by hand, but use technology to double check those values to make sure you're on the right track. Let's check out some more of these together.